Imagine embarking on a journey across an endless, featureless expanse, traveling thousands of miles without a map, compass, or even a recognizable landmark. Now imagine that, after this immense trek, you not only find your way back to the exact continent you started from, but to the precise spot, perhaps even the same nest, you left months ago. This seemingly impossible feat is a routine part of life for many penguin species, a testament to an extraordinary inherent wisdom that guides them through the world's most challenging environments. For species like the Adelie or emperor penguins, migration is a fundamental part of their life cycle. After breeding and raising their chicks in vast, bustling colonies on the Antarctic coast, they embark on lengthy foraging trips into the open ocean. These journeys can take them hundreds or even thousands of miles away from their home, driven by the search for abundant food resources. Yet, when the next breeding season calls, they invariably begin their arduous return, compelled by an unerring instinct to reach the familiar shores of their birth. The open ocean presents the ultimate navigational puzzle. There are no signposts, no mountain ranges, no fixed points of reference for hundreds, sometimes thousands, of miles. The waves all look the same, the horizon indistinguishable in every direction. For a creature that primarily exists at the surface or just below, how do penguins maintain a sense of direction over such immense distances? How do they consistently choose the correct path that leads them back to their specific patch of frozen land? One of the most remarkable tools in a penguin's navigational arsenal is an inherent ability to detect Earth's magnetic field. This invisible force field, generated by the planet's molten core, envelopes our entire globe, forming distinct lines of magnetic force. For centuries, humans have relied on compasses to align with this field, but penguins, it appears, carry their own highly sensitive, internal version, allowing them to sense direction without any external device. It's an innate compass, guiding them across the trackless ocean. Precisely how penguins perceive the subtle nuances of the magnetic field remains a subject of ongoing scientific inquiry, but evidence strongly suggests they possess specialized cells within their eyes or beak that act as magnetoreceptors. These specialized structures could allow them to see the magnetic field, perhaps as patterns of light polarization, or even detect minute changes in intensity and inclination. This remarkable sensory input provides a reliable, global map, regardless of weather conditions or time of day, a true marvel of natural design. While the magnetic field offers a constant directional bearing, penguins also employ another powerful celestial tool, the sun. Just as ancient mariners used the sun's position to navigate, penguins possess an internal sun compass. By tracking the sun's arc across the sky, they can maintain a consistent heading throughout the day. This requires not just seeing the sun, but also knowing what time of day it is, compensating for the sun's apparent movement. It's a sophisticated calculation, performed instinctively. For the sun compass to be effective, penguins must possess an accurate internal clock. This biological timepiece allows them to compensate for the sun's movement as it traverses the sky. Without it, their directional heading would shift throughout the day. This innate circadian rhythm, synchronized with the cycle of day and night, ensures that their sun map remains precise, guiding them along a straight and true course. It is an indispensable partner to their sun tracking abilities, enabling long-distance accuracy. But what happens on overcast days, when the sun is hidden behind a blanket of clouds? While some birds are known to detect polarized light, a phenomenon that allows them to infer the sun's position even when obscured, penguins likely rely more heavily on their magnetic sense during such conditions. The magnetic field offers a consistent, weather-independent directional cue, acting as a crucial backup system. This demonstrates a flexible and redundant navigational strategy, ensuring they are never truly lost, even in the most challenging weather. As penguins approach their destination, a new sensory input becomes critical: olfaction, or the sense of smell. The open ocean has few discernible scents, but a penguin colony, home to thousands of birds, guano, and nesting materials, emits a strong, unique olfactory signature. Studies suggest that penguins, especially those returning to specific breeding grounds, may use these airborne chemical cues to pinpoint their exact colony and even their specific nesting area. It's like following a scent trail home after a long journey. Each large penguin colony likely possesses a distinctive blend of scents, a chemical fingerprint created by the unique mix of species, guano, diet, and local flora. It's plausible that young penguins imprint on these specific smells during their first few weeks or months of life, creating an indelible memory of home. Later, after months or years at sea, this memory, triggered by the faintest airborne particles, guides them with remarkable precision to their ancestral breeding grounds. This subtle sense allows for an incredibly specific return. Beyond the celestial and magnetic realms, penguins spend much of their migratory lives beneath the waves. While direct evidence is still emerging, it's possible they also gather navigational information from their aquatic environment. Detecting subtle changes in water temperature, salinity, or even the direction of ocean currents could provide additional, localized clues. These underwater signals might not act as primary compasses, but they could refine a penguin's path, helping them stay within productive foraging zones or direct them towards their destination. The true genius of penguin navigation lies not in a single extraordinary sense, but in the sophisticated integration of multiple sensory inputs. They don't just use a magnetic compass or a sun compass, they combine them. They use global cues for long-distance travel, then switch to more localized cues like scent as they approach their specific colony. This layered approach, using redundant systems, ensures their incredible accuracy and resilience against environmental variations. It's a complex, dynamic system of inherent knowledge. What drives this relentless return to the same patch of land, year after year? It's a powerful homing instinct, deeply embedded in their natural disposition. Returning to the familiar colony ensures they find a mate, contributes to the continuation of their lineage, and brings them back to a proven breeding ground with established social structures. This innate compulsion, combined with their extraordinary navigational capacities, forms an unbreakable bond between the penguins and their specific home, a true testament to natural design. The marvel isn't just returning to the continent, but to the exact colony, sometimes to the very same nest site, or within a few feet of it, year after year. This level of precision is astounding, given the vast distances covered. It suggests a finely tuned internal GPS system, constantly updating its position based on the myriad of sensory data collected. They are not merely finding land, they are finding home with unparalleled accuracy, a feat that continues to astonish researchers. Upon returning to the cacophony of a bustling colony, penguins often reunite with their mate from previous seasons. How do they find one specific partner amidst tens of thousands of identical-looking birds? Here, sound likely plays a critical role. Each penguin has a unique vocalization, a distinct call that helps its mate and chicks identify it. The blend of navigational prowess, combined with specific auditory recognition, ensures the continuity of their family unit, a remarkable example of individual recognition within a vast community. For many penguin species, these incredible migratory journeys are not a one-time event, but a repeated cycle throughout their lives. Each year brings a new challenge of navigation, a renewed test of their inherent abilities. From young adults embarking on their first epic foraging trips to seasoned veterans returning to their familiar breeding grounds, the navigational systems are constantly in use, guiding them through the planet's harshest environments. It is a continuous demonstration of profound natural wisdom and adaptation. Despite decades of research, the intricate mechanisms behind penguin navigation continue to unveil new layers of complexity. While we understand the key senses involved, magnetic, solar, and olfactory, the exact interplay in neural processing remains subjects of active study. Each discovery deepens our appreciation for the astonishing capacities of these birds. The ongoing effort to understand how penguins achieve this feat highlights the profound wisdom embedded within the natural world, a marvel waiting to be fully understood. The ability of penguins to navigate thousands of miles across featureless oceans and return with pinpoint accuracy to their specific colony is one of nature's most astounding stories. It speaks to an inherent design, a comprehensive suite of sensory tools and instincts that allows them to thrive in environments that would confound even the most advanced human navigators. Their journeys are not random wanderings, but purposeful expeditions, guided by an invisible web of information that is both profoundly complex and beautifully simple.